All right, boys and girls, in this video, we're going to look at a couple of things. We're going to find zeros when the polynomial is in factored form. And we're also going to find the roots and the degree, all when it's in factored form. So if we look at, there's two steps to find the zeros, very easy steps. One is set each factor equal to 0, and two, solve the one or two-step equation it creates. So if we look at this and we want to determine the degrees and the maximum number of roots, what we have to do is we have to look at that each of these linear factors are to the degree 1. And so if I were to multiply this out, I would get x times x times x. So the highest degree would be x cubed. So the degree of this is 3, which means the total number of roots, the maximum total number of roots is 3. And the actual total number of roots we're going to find. So to find the roots, we're going to set each of these equal to 0. So we're going to set this expression equal to 0, this expression equal to 0, and this expression equal to 0. We're going to set them all equal to 0 because there's a rule that says if I multiply two things together and get 0, one of them has to be 0. So that means either x minus 2 is 0, x plus 4 is 0, or x minus 7 is 0. So solving this one-step equation, I get x equals 2, subtract 4 from both sides, I get x equals negative 4, add 7 to both sides, I get x equals 7. So I have 3 distinct solutions. And so the value of all my roots are going to be 2, negative 4, and 7. And remember, that's a solution set, and it verifies with the maximum number of roots we said would be 3, and there are 3 roots. Okay? So first, let's find the degree of this polynomial, and we start by saying we have a second degree and a third degree, so we add those together, and this becomes a 5th degree polynomial. And I got that because 2 plus 3. All right, I set each factor equal to 0 to see exactly how many factors I have. So to set each factor equal to 0, I'm going to have x plus 1 squared equals 0, and x minus 3 cubed is equal to 0. So how would I solve that? Do I want to multiply that out? Well, I could, but probably the easiest way is just to take the square root of both sides. So that's going to give me just x plus 1 equals 0. If I take the cube root of both sides, I get x minus 3 equals 0. So I'm not going to do that in future ones, but I just wanted to show you how we were getting that. So this becomes subtract 1 from both sides, that x is equal to negative 1. And then if we add 3 to both sides, we get x equals 3. So our solutions are negative 1 and 3. So how many real solutions did it have? How many solutions did it have total? Were 2, even though it's a 5th degree polynomial. Now we're going to use a term later, and we're going to call this multiplicity. We're going to talk about that term tomorrow, but this is multiplicity. So what we say is that this x plus 1, the reason it's squared and it represents only one solution because of the multiplicity of 2. Okay? So let's look at our next problem. What is the degree of this problem? Well, remember here, there's a degree of 1, there's a degree of 4, and there's a degree of 1. Even though we don't see it, it's understood that there's a degree of 1 and 1 here. So this has a degree of 4, 5, 6. So it has 6 possible roots, but let's see how many it actually has. So we have to set each factor equal to 0. So that's going to be x is equal to 0, x minus 5 is equal to 0, and x minus 3 is equal to 0. What most kids forget is they forget this one. So that is a 0. We can't solve it, so it's just 0. So we're going to add, for this one, we add 5 to both sides. We get x is equal to 5. We add 3 to each side. We get x is equal to 3. So we have 3 solutions, and those solutions are 0, 5, and 3. And this has a multiplicity. X equals 5 has a multiplicity of 4, and x equals 3 has a multiplicity of 1. So we really don't call that a multiplicity because it's just 1. Okay? So let's do the next one. And what are our terms here? So we have x plus 3. We have 3x plus 4. Because 2 does not have an x, it doesn't count in the degree. So this is a second degree polynomial because we have a 1 here and a 1 here. So this is a second degree polynomial, and we're going to have 2 factors. So we have x plus 3 and 3x plus 4. So this becomes, notice for most of these we're just taking the opposite, so that becomes x equals negative 3. We subtract 4. We get 3x is equal to negative 4. This is a two-step equation, so we have another step. We have to divide by 3, so we get x equals negative 4/3. So this has 2 solutions, and those solutions are negative 3 and negative 4/3. Okay? So we have 2 more to do. I would like for you to pause the video and just take a second and finish that up, and come back and we'll go over it. Alrighty, welcome back. Let me just fix this a little bit because it's going to bother me. This is 3x is equal to negative 4. And so then we did 3x is equal to negative 4 divided by 3. Okay, just wanted to fix that up. All right, so for this one, we only have 1 solution, even though it is a third degree polynomial. Again, we don't count the 3 because it doesn't have an x next to it. So this is a third degree polynomial, and it has only 1 solution, x equals 1. For this one, it is a 5/6 degree polynomial, and it has 3 solutions. So our 3 solutions are x equals 0, x equals negative 5, and x equals 6. And so it's 3 solutions, and those are the solutions. Okay? All right, we're going to do a little practice with this, but you have another lesson to do today. So come back for the second lesson in a minute.